I was supposed to go outside for today's video, but lucky for me it's raining, and that is a relief because now that I'm YouTube famous, I don't have to mix with the general public anymore. Oh, haven't you heard? I've got 200 subscribers. No, but seriously, if you're someone who's after subscribing to the channel, I really appreciate it. It makes a massive difference going forward, and I'm just really thankful. But if you're new here, my name's TeachwithTadgh. I try and teach science by using memes and gifs and making jokes that make you go, yeah, that's kind of funny. So if that sounds like a bit of you, make sure to hit that subscribe button and click the bell for notifications. And tell me in the comments which one of the memes I used today was your favorite. Now in today's video, we're looking at speed and velocity. And if you watch to the end, I'll give you a bonus tip for your exams. So make sure to stick around. Now in my previous video, I told you that speed and velocity were examples of scalars and vectors. If you want to watch that video, there's a link on screen now, but make sure to come back and watch this video afterwards. Why am I whispering? Now speed is a scalar. We measure it by looking at the distance you travel over a given period of time. It's got this equation here. Velocity is similar, except velocity's got direction. So it's more like looking at displacement. It's about how long it takes you to get from point A to point B. It doesn't matter the distance you traveled from point A to B. So that's how it's slightly different. Okay, let's do an example. Imagine it's the school sports day and all the teachers are lining up for that 100-meter staff race. The gun goes off. Bang! Of course, your boys representing, everyone expects it to be a close race. But that Irish science teacher steams ahead, leaving everyone in cloud dust. So let's take some of the data from that race and let's see what speed I was traveling at. We know the distance was 100 meters and the time it took me to run it was... That is significantly underwhelming. Can we make me look a little bit better, please? Much better. So if we divide 100 meters by the 12 seconds, we work out I'm traveling at 8.3 meters per second. Seems straightforward. Now in an exam, you need to remember this equation because you won't be given it. And you could be asked to calculate any of those three components. So make sure to remember this magic triangle. You can use it to figure out how to rearrange that equation to find the thing you're looking for. Okay, time for an example for you to try. So every summer I take part in the street legal teacher drag race, where I take on my arch nemesis. Unfortunately, because we're teachers, our cars are pretty awful. And they max out at 30 miles an hour, which is about 13.4 meters per second. Now the race is a mile long, which is 1,609 meters.
Welcome back to freesciencelessons.co.uk.
So can you calculate for me how long it would take us to complete that race? I'll just wait here. So we start by rearranging the speed equation to get time instead. And time is equal to distance divided by speed. We put in 1609 divided by the 13.4 meters per second, and that gives us 120 seconds, or about 2 minutes. Now in an exam, you could also be asked about this thing called a distance time graph, which tells you how far from a start point you're after going over a period of time. So let's have a go at making one. You're in school and the lunch bell goes. So you do what every student does and you start running to the canteen. And you're covering a lot of distance in a short period of time. However, on the way you get stopped by the English teacher and they stop you for a little while and tell you should be running in the hallway. Yo, why is it always the English teachers? So then you have to do that like weird speed walk we all do until that English teacher can't see you anymore, and then you go back running straight away. You get to the canteen, you get your food, and then you walk back to where you started. Let's create a graph that looks like that. So if we look at the graph, you can see the different points of that story. At the start, we've got the point where you're traveling really fast. That horizontal line is where you were stopped by the teacher. The slight slope upwards was when you were speed walking. And then we can see the increase in speed again. That line coming back down is where you're walking back to the start point. Now those slopes are actually really important because we can use them to calculate the speed at any given time. Take 2 points on any of those slopes, get the y2 and y1 points, and get the x2 and x1 points on that slope, and you can use it to calculate the speed. The formula you need to use is y2 minus y1 divided by x2 minus x1, because it shows you the distance you traveled in between those 2 points and the time between those 2 points. Right, if you've managed to make it to this point of the video, you deserve to have those bonus tips for your exams. So here they are. In the exam, they might expect you to know some typical values for everyday speeds. Walking is 1.5 meters per second, running is 3 meters per second, and cycling is 6 meters per second. They also have the speed of sound, which is 330 meters per second. I'm gonna get ruined for saying it like that.
My life, it's potato.
The other tip I have is that speed could remain constant, but your velocity could be changing because you're changing direction. It's a bit like walking through town and you see your X, so you change direction immediately to avoid them. You're changing your direction, but your speed might remain constant. We see this quite a lot with circular motion. If you enjoyed that video, please hit that like button, maybe hit subscribe, or if you're doing your exams, just share this with a friend. You never know, they might find it useful. You can also go check out my content for GCSE Chemistry, or find me on Instagram and TikTok, just search TeachwithTadgh. I post new content daily. Now let's go past them GCSEs.
I am the one, the way your son don't need a gun to get respect up on the street.